Hello everyone, welcome to this session on sand casting, solidification and cooling. Sand casting is one of the oldest and most widely used manufacturing process in the metal industry. In this lecture, we will first understand the basic principle of sand casting, become familiar with the important terminologies used in the mold design, study the complete casting methodology, and finally we are going to learn how the molten metal solidifies and cools inside the mold. Let us begin with the basic concept of sand casting. Sand casting is a manufacturing process in which molten metal is pouring into a mold cavity prepared using green sand. This molten metal flows into the cavity under the influence of gravity or any other external pressure. After filling the cavity completely, the metal is allowed to cool and solidify. Once solidification is complete, the mold is broken to obtain the final casting. As we have discussed previously, this process is nearly 6,000 years before, making it one of the oldest manufacturing technique which is known to the mankind. The principle of casting is first the metal is to melt in a furnace, then the molten metal is poured into the mold, and finally we will let it to cool and solidify. Casting is used not only for manufacturing finished components but also for producing ingots that serves as a raw material for other operation like lathe operation, drilling or any other manufacturing process. Before understanding the casting process, it is important to know the terminology used in the sand casting. The first term is flask or molding box. It is the frame that holds the molding sand during the molding preparation. The lower portion of a flask is called as a drag, right? So this is going to be the lower portion and this is going to be the upper portion. That upper portion is going to be called as a cope. The next terminology is pattern. A pattern is a simple replica of a final component, right? So what kind of a component we are going to cast, that is going to be made as a pattern, whether it is going to be the gear or whether it is going to be any shaft or key, right? So that we are going to make as a pattern, right? And it is used to make a final component, and this pattern is usually made up of wood, metal, plastic and any other easy material like cast, right? Sorry, like wax material. So the next is the parting line. So it is the surface that separates the cope and drag. That means the upper portion and the lower portion will be separated with a line. That line is going to be the parting line. Here you can able to see the dotted lines. That is going to be the parted line. This line allows the two halves of mold to be assembled and separately easily. The other important material is called as a molding sand, right? It is primarily composed of silica sand mixed with clay and moisture. This sand must possess sufficient strength to retain the mold shape while remaining permeable enough to allow gases to escape during pouring. Because using this sand only we are going to make the mold, right? If it is not strong enough, when we are keeping the pattern and we are trying for any molding operation, it will collapse, right? So this molding sand should have a required strength. Finally, phasing sand. So this is a special kind of a sand. This will create a special layer on the sand placed directly over the mold cavity, right? So as we discussed, this is going to be the pattern. This is going to be the mold sand. The phasing sand will be have a small layer here. Why we are using this phasing sand means because it will create a better surface finish once the process happen. Now let us continue with the terminology. So the next important thing is the pouring basin or runner, right? So this is a funnel shaped opening where molten material will be poured. Here only our molten material will be poured, right? From the pouring basin, the metal enters the sphere. So this is called as a sphere. This passage is called as a sphere, which is the vertical channel carrying the molten material down to the mold, right? So this sphere will carry the molten material. Then it will falls to the runner. So the runner is the horizontal passage, right? So remember, vertical passage is called as a sphere and horizontal passage is going to be a runner, right? So this distribute the molten metal to the different section of mold, right? You can able to see the different sections. This is going to be one section, riser is going to be the one section, and this is going to be the mold will be the another section. Finally, the mold enters the mold cavity through the gate, right? So this portion will be called as a gate, right? We are going to see detail about the gate in the further session, which controls the entry of molten metal into the cast, right? And also we have another important feature in the casting, that is going to be a riser. So a molten metal cools, right? Whenever the molten metal from the liquid to the solid, there will be some shrinkage, right? To compensate this shrinkage, this riser act as a reservoir of a liquid metal, right? Generally, we will pour the material. Some material will enter in this mold cavity and some will go to the riser. Whenever it starts to solidify, that means the entire area will be started to shrink further. So during that time, the excess material from this riser will get into the mold cavity to compensate that, right? Some casting requires some internal holes or cavities. To create that internal holes, we will be using the core, which separates the sand components placed inside the mold before it's pouring, right? So this is going to be the core. When you are going to use the core, we can able to have the internal structure like this, right? Internal structure like this. Since core are supported by the molten metal, they need some support. So this support is provided by the material or terminology called chaplet, which holds the core in its correct position and prevent further movement. So now let us discuss in detail about the casting process. So the process begins with preparing the pattern and producing the mold using sand. If internal cavities are required, suitable cores are also prepared along with the pattern. The mold halves are assembled, ensuring proper alignment of the gating system, runners, gates and risers, which is happened in the pouring basin. Meanwhile, the required metal is melted in a furnace until it reaches the desired pouring temperature. That means it's supposed to have a liquid state. The molten metal is then poured carefully in the pouring basin, right? It flows through the sphere. As I said, it will flow through the sphere, then to the runner and finally into the gate. After entering to the gate, it will get into the mold cavity. The mold is left undisturbed while the metal solidifies and cools. Once the solidification is completed, the mold is broken out, the cast is removed, gates and risers are cut off, and the final operations such as grinding, cleaning and inspection are carried out before casting is ready to serve literally. Now we shall move on to the next important topic in the casting, which is going to be the solidification and cooling, because this is going to define the entire structure of a casting. As soon as the molten metal enters the mold, it starts transforming heat to surrounding sand. So gradually the temperature decreases until the liquid transforms into a solid. The manner in which solidification occurs depends on whether the material is a pure metal or an alloy. There is two important terms should be remembered while you are talking about the casting solidification. The first is the local solidification time, which is the time required for a particular section of casting to change completely from liquid to solid. The next one is total solidification time, which is the total time taken from pouring until the entire casting has completely solidified. Proper control of solidification is essential because it determines the grain structure, mechanical properties, and occurrence of defects such as shrinkage cavity and porosity. Now let us see the cooling behavior of both pure metal and the alloy. For the pure metal, the temperature decreases steadily until it reaches its melting point. At this point, solidification begins and the temperature remains constant while latent heat of fusion is released. Once the solidification is complete, the temperature again starts decreasing further. In contrast to the pure metal, an alloy does not have a solidify at a single temperature, because in alloy we are going to have two or more material. Instead, it solidifies gradually over the temperature range, right? So the solidification happens between this temperature range between the liquidus and solidus temperature. During this interval, both liquid and solid phase are coexist. The phase diagram shows here help us the understand the transformation. Using this phase diagram, we can able to understand how the cooling curve for alloy will be happen, right? So while cooling curve illustrate how the temperature changes within the time during the solidification. So these cooling characteristics directly influence the microstructure and also the final mechanical property of a casting. And thank you for your attention. In this lecture, we have discussed about the basic principles of sand casting and its terminology, and finally the cooling and solidification concepts of casting. Thank you.